What's up, everybody? Welcome to week 345 million of distance learning, or at least I know that's what it feels like to me. I'm sure a lot of you guys feel the same way. But just keep grinding, keep doing it. So, more important timeline: 4 weeks till the day of our AP exam-ish. 2 weeks of learning, 2 weeks of AP exam prep for everyone, and then 2 weeks of exams starting on Monday, May 11th. So this is a big 2 weeks for us here, not just thinking about stats, but thinking about all of our courses. So let's just, let's keep pushing, give our best. And that being said, let's jump into some new stuff. So hopefully this isn't super surprising to us. Started with one proportion Z stuff, tests and intervals. How do we draw conclusions about one population proportion based on one sample proportion? Then we moved into two prop Z stuff. How do we draw conclusions about a difference in two population proportions based on a difference in two sample proportions? And so now we're just following that same path. We started last week looking at how do we draw conclusions about one population mean based on one sample mean. And so of course now we want to look at how can we draw conclusions about the difference in two population means based on the difference in two sample means. So that was like a really long way of saying hopefully you guys saw this coming. As we start to get into all of this, conceptually, this is going to be pretty much the same stuff as our two prop Z test intervals, right? The formulas are going to change. There's no more P's. Now there's going to be U's, right? The notation will change, but conceptually, the ideas are the same. So maybe it's a good idea to go back and rewatch that video. If you didn't watch that video, you definitely need to watch that video first. It goes more into kind of that understanding more about the why. Here we'll move a little quicker and just focus a little more on the how. And just like, how do we do a free response in the exam? So like things like, right, we have two samples. We're going to focus on the difference in our parameters and our statistics. Still got that fourth condition, right? Still assume no difference in a null hypothesis, right? It's the kind of way we write these things, right? That's all the same. So I'm not talking about you. Come here. Come here. All right. Special guest presenter. Come here, buddy. I'm not talking about you. Say hi.
Are you doing it? I thought in the blue one.
Oh, all right. You're going to do your statistics in blue?
Yeah.
Say bye, everybody.
Bye, everybody.
Say, do your homework. Can you shut that door behind you? Sorry. That one's closed already, dude. No, close that one on your way out. Sorry, hopefully you fast forwarded through all that if it was boring. Anyways, context. Give the video a pause and write that down. I think this week I'm going to ask for pictures of some of your notes as part of the effort grade component, which I didn't mention in the video. It's a brilliant idea popping in the noggin here. We'll see, right? We're figuring this all out as we go. That's the theme. So let me know what you think. But on a notes note, here's our context. As you read this, so we have two samples. Maybe it's a good idea to make one of those T-charts like we did with our two prop Z stuff. And then really I want you to think about this question here. Think about how would you do this? How would you estimate the difference in mean wait times for males and females using 98% confidence? All right, there's gonna be a process to that. Hopefully you have some thoughts about what it is. And honestly, try it. I think that you probably could do this entire problem and then just kind of go through the video to verify your ideas. If we were in class, I'd pop you guys in a group and I know you would figure this out. So challenge yourself. Try to just do the whole thing right now. But if not, hopefully the first thing you're going to do, right? Same process, conditions, math, interpret our interval. And then here's my little T-chart, if you wanted to make one of those. So let's do it. Conditions, right? Like same deal as last week, except now we got to do them twice. And we always have that independent groups. So give the video a pause. Maybe try to check these conditions if you didn't already. So both samples are random, right? We always want random samples. Both samples are large enough. That's much easier and much more efficient to write than
in a game hole.
Oh.
It was in a cave hole.
I have no idea what you just
These aren't open.
Close, please. Close, please. Thank you. Both samples are less than 10% of their respective populations. And this one's just in a different color blue because this didn't show up last week, right? This is just coming back that independent groups. So what we're saying with independent groups is like, we don't want the wait times for the males group to be related to the wait time for females. Like if they were all in the same line, then their wait times would be related, right? If it was just one line of people. Or maybe if it was, you know, my Mrs. Carafano and I were together, right? Then our wait times would be related. Since we have 141 random women and 145 random dudes, like there's no reason to think that the wait times of those 145 random men are related to those of the 141 random women. So that's kind of why that's coming back to the randomization condition. Can write everything the blue way. That's what I would do. Add some context, right? But the black are just different ways you might write these conditions. So that's that. So next up, math. Got to make our interval. So hopefully you're thinking, you're grabbing your calculator. We're looking now at our 2 sample T interval, right? We have 2 samples of data, men and women. We're working with means. That's why it's T. And we're estimating, and we were given a confidence level. So that's why it's an interval. One thing I want to point out here, when we do the 2 sample T intervals and tests, you're going to see this. We're always going to pick no for pooled. I'm not going to lie. I don't even know what that means. I'm serious. I don't know what that means. So yeah, always pick no. So you can see I've entered all the data there. No big deal. Got our confidence level. And now let's think about the formula. So going back to the 2 sample T, to the 2 proportion Z intervals, right? The ideas are the same. So let me jump to the whiteboard. You know, for any confidence interval, it's our statistic plus or minus our critical value times the standard error of that statistic. The thing is, now we don't just have one statistic, right? We have 2 sample statistics. We have a one sample mean we might go for like men and a sample mean for women. But anytime we have 2 statistics, 2 parameters, we focus on the difference in them. Plus or minus. Now this is going to be our T star, which we could not look up with our table, because if you notice, so with 2 samples, it's not just n minus 1. It can't be, because there's not one n. So for 2 samples, there's a formula for how to calculate degrees of freedom. We don't have to worry about that. Calculator is going to spit out the degrees of freedom, right? But notice that it's like a weird number, right? A decimal, not something we can look up in the table. It is something we could use inverse T to figure out if we have a calculator with that feature. But the idea is, right, we have T star here based on some degrees of freedom. And then if I look at my AP formula sheet, we're taking now the sample standard deviation for the men squared over the sample size for the men plus the sample standard deviation for the women squared over the sample size for the women. And on a side note, this is just the idea that variances always add, right? So if I have like Sx over square root of n1 plus Sx2 over the square root of n2, right? We cannot add standard deviations. Variances always add. And that's how we end up with this squared over just n and this squared over just n. But then, of course, to turn it back into a standard deviation, we have to take the square root. And so you can see that's where this blue formula up here is coming from. Review. It all fits back. Variances always add, right? And so this is the formula that we're going to use to create that 2 sample T interval that is on the screen in a second. All right. Where we go? Quick. Boom. So that's all you're seeing here. Subtract our 2 sample means. We got men minus women. Notice here I just wrote T star. There's that weird 243.03 degrees of freedom. Right now I'm just going to write T star, showing we understand that's what would go there. Going back to last week's video about the T distribution, I could use inverse T to figure out that T star, but I'm not going to find 243.03 in my T table. I'm probably not going to find 243 either. All right. Next up, we should probably know we got to interpret this interval. There's 2 ways we could go about it, just like with 2 prop Z. So we could just focus on this wording, right? The difference in mean wait time for males and females. Just make sure you include the order of subtraction, because that's how we make sense out of the negative or positive numbers. So personally, if I'm taking the exam, I'm just going to say something about the true difference in mean wait time for males and females. And then you wrote a sentence right now, hopefully, and hopefully it looks something like this. So we could say we're 98% confident the true difference in mean wait times for males and females at a coffee shop, M minus F. We want to include the order of subtraction again, because that's how we make sense out of these negative numbers And that'll come up in this next slide, right? These are not wait times. Wait times cannot be negative. These are differences in mean wait times. And on that note, right, this has to be there. If you just said difference in wait times, that's an incorrect statement, right? So this whole entire interpretation would be false. So that's one way we can interpret this interval, and that's probably, like, that's what I would do if I'm just doing a free response on the exam. But the other option, like the more meaningful interpretation, is to think about, what do these negative numbers mean? So our other option is consider the sign, the positive or negative of the two values in the interval, remembering that we subtracted m minus f. So think about it to yourself. This interval is suggesting that one of the groups has a larger mean wait time. Which one, based on, right, that order and the fact that both of these are negative? And hopefully we realize that the only way that could happen to get a negative difference would be if this, right, this has to be the bigger number, right? If we're going to do m minus f and get a negative number, the only way that's going to occur is if this, the mean for the f group, was larger. And as a result, another interpretation is now, we're pretty sure, we're 98% confident that the mean wait time for the females is bigger. And again, that's because m minus f gave us a negative difference. How much bigger is the mean wait time for females? Somewhere between 10.8 and 46.2 seconds. Right? And so now in my sloppy handwriting, that's what we can see here, another way to interpret that interval. We're 98% sure the mean waiting time for female coffee shop customers is between 10.8 and 46.2 seconds longer than that of the males. Right, so that's it. Same deal as always. Conditions, math, interpret. And then we probably should not be surprised. We're going to see questions like this, very similar to what we saw with 2 prop Z. So based on this interval, now a second question, is there evidence that the mean wait time significantly differs for males and females? Pause it up. Try it out. What we always want to come back to is we want to remember that when we're looking at 2 samples, we're curious about that 0, right? So if we're going to do m minus w, right, the only way that would be 0 is if these are the same number. So 0 represents no difference in mean wait times. So if our interval contains 0, that means it's possible that m and w were the same, because that's how you get m minus w, right? That's how you would get a difference of 0. So we want to think, does our interval contain 0? If so, we don't believe there's a significant difference, because that true difference might be 0. If our interval doesn't contain 0, then there is a significant difference, because we don't think, right, if there's no 0 in the interval, that means we don't think m and w, the mean for men and women, could have been the same. Right? And so here there is evidence the mean wait time significantly differs for males and females, because 0 is not in the interval. That's the most concise way to write that, what you see in blue. And then in green is going back to what we saw on the last slide. The fact that the interval is entirely negative tells us we think the mean wait time for females is longer. Last question, and we're all done here. And then for practice 2009 free response, you'll see really similar setup to this. Miss y'all. One more question though. Difference in means versus mean difference. That's a really, really big deal. So this is a more conceptual idea, but this is also something we could avoid by copying the wording out of the context. So to finish up this video, I'm going to hop over to the whiteboard and then we'll call it. Tomorrow you got 2 sample T tests, and then we're getting close here, wrapping up the new stuff, and this will all become review. Nonetheless, so here's the deal. So if we're talking difference in means versus mean difference. So here's the deal. These are 2 very different things. Difference in means is literally saying you have 2 means and you take the difference in them. That's what we just did, right? We started with the difference in 2 sample means and are going to use that information to try to draw conclusions about the 2 population means. So a difference in means, right, is literally we're subtracting means, and this is all the 2 sample T stuff. That's what's happening this week. But mean difference means something very different. I didn't even do that on purpose. A mean difference is not saying you look at two averages and find the difference in them. A mean difference is saying you find an average of the differences. So this would be, we first create a list of differences. So by that I mean, like we would take each men's time minus each women's time, right? And then we would create an entirely new data set, like whatever, pretend that's 10 and 9, right? There's our difference, or 3 and 9, right? That's -6. We create an entirely new data set of differences. So mean difference is saying you create that list of differences, then find the mean of those differences. And we would use that to draw conclusions about the population mean, right, of all theoretical differences. This is something called a paired t-test or interval. So those are very different things, right? And so that's kind of the idea, well, not kind of, that is the idea. That's the difference, the distinction between difference in means versus mean difference. This for us is chapter 24. This for us is chapter 25, and they're different types of test and intervals. So this week, difference in means. All right. Hey, bud. Have a good day, everybody. Do your homework.
We should do it.
See you soon.
We should line up my car.